Hi guys, I'm Darren and this is the 5th instalment of our iNav 5 Build Academy. We'll be carrying on with the Dolphin and getting our FPV components installed. So firstly, I just want to apologise if you can hear my little fan. It's hot today, I need it on. So sorry if that's sort of interfering with the sound. Hopefully it isn't, but I won't know until I start editing this thing. Also, before we get going, I do have a couple of shout outs to new patrons who join me on the pilot level or above. That is David Gardner and Stephen Huff. So thank you very much, guys. And thank you to everyone who's been showing the channel support. I really do appreciate it. While on the subject, just to get all that side out of the way so we can get on with the build, if you have been kind enough to leave me a super thanks on YouTube, thank you very much. Unfortunately, on the mobile phone app, it doesn't actually tell you if someone's left you a super thanks or not. So I'm trying to catch everyone and thank them personally on the YouTube app, but if I haven't, please don't take that the wrong way. I'm going to contact YouTube and see if they can sort it out, because it really should be brought to people's attention. But thank you very much, guys. I really do appreciate it all. Just for a brief recap where we're at, we've done an initial setup of iNav just to get the calibration and everything that we can do outside of the plane done. We've got our flight controller installed in the plane, everything's glued together, we've got our pins installed, everything is ready to go. So what we're going to do now is get on and get the FPV components installed. Okay, so what are we going to get done in this video? Well, we're going to get an FPV camera installed, we're going to get our servos attached, which you can see we'll need to extend the leads a little bit. We're going to get our receiver on, our GPS, basically everything so that we can fly basically. If you remember in the last video, we sort of eyed up roughly where we're going to put our components to make sure that the CG would be about right, and we've got plenty of room at the front to move a battery backwards and forwards. Of course, if you're using different batteries, you'll want to get that right with the battery you're using. So be wary of that when we're setting all this stuff up. Alright, so I figure we may as well get started with the video side on this side of the aircraft. So as I mentioned in the last video, I wanted to get some extension cables, and I was stupid and ordered some that were a little bit too long. But to be honest, there wasn't really a lot of choice out there. So these are 15 centimeters, 10 would actually be ideal. I'm going for the RG316 cable, which is actually what the braided cable is here. There is a thinner cable available, but it's you probably get a bit more loss through that. This is a better cable to use. Also, I found getting the angled connector was pretty difficult, and I didn't want to use an angled jack with a straight connector on it, because you do get loss through that as well. So what I'm going to do is actually use a connector that I already have. So this is the cable I'll be using for sort of setting up the demo, and I believe this is a RG176 cable, so it's a thinner cable, not so good. And also it has an angled MMCX where I'd have preferred straight. But while I've got this out, it'll be easier to show you a few things to watch out for if you do want to order a different cable. And to be honest, the main one is just make sure that it matches your antenna. These are both SMA connectors. There's two different types of SMA connector. There is this, which is the standard, where sort of the antenna side, which has got the nut on it, has got a pin in the middle, and the side that just has the thread has a hole. And there's also RP-SMA, which is reverse polarized SMA, where the one with the nut on it has the hole in it, and the one with the thread has the pin. Obviously, if you have two with holes, it won't work, because the center is not connected, and if you have two with pins, they won't go together anyway. So just make sure that you are using both the same type. If you're in any doubt, order an SMA antenna and an SMA cable and you'll be fine. So let's get this in the plane. So this plywood plate, it doesn't actually matter which way up that you put it. I will not be gluing this in permanently, because I will be moving this out at some point, and I will also be using this connection for ESP32 radar, which, if you're new to this, you probably don't know what that is. It's a device that runs off of an ESP32, which will actually point to where your flying buddies are if they also have radar installed. It's a pretty cool system. So I'll be using that antenna space there for that, and I'll be putting the VTX out on the wings. So I'm just going to stick this on here. Now, I did actually learn yesterday that SMA cables are a 7.9mm nut, but an 8mm socket or spanner works absolutely fine. So that's tight enough. If you're installing this permanently, put some glue down here, and then all we're going to do is put it up through the hole. So yeah, if you install it permanently, just hold it up in there, get that nice and glued in tight. What I will be doing is, once everything's installed, I'm going to shove some foam in there just to hold it up temporarily until I get everything where I want it in the final position. So our antenna will of course just screw in on that, and that will all be good. So next up, let's take a look at the VTX. I'm going to take the antenna off just to make things easier. So this is the video transmitter I'm going to be using, which has the MMCX connector, which is why I needed a different cable. The standard cable is SMA, so it's got a hole on the threaded side, is a UFL or IPEX1 connector, which these are fine for VTXs like Team Black Sheep. VTXs seem to use these. Personally, I'm not a fan. They're too small and dainty for my liking. MMCX is about perfect as far as VTX antennas go. SMA, it's stronger and more robust, but it's also heavier, bigger and more bulky. So I think MMCX is about, you know, the right place. So to connect them, you just click it together and that's it, done. So that video transmitter, I'm going to put probably there somewhere like that so I can still get to that screw. And again, I'm just going to temporarily fix it down. On this side, we've got a couple of indicators. We've got a button to change channel and power, that sort of thing, or we can connect up the smart audio. So what I'm going to do is get the plug out, and we're going to have a look at how to set up the basic VTX. Right, so with your video transmitter, you will most likely get a cable and an instruction manual. Now, these AKK video transmitters are actually pretty decent. I've measured the power output of them. They're all bang on what they say they should be. So yeah, they are decent. But of course, you can choose what you want. There are other more expensive and better quality units out there, like for example, the Rush Tank Solo, that sort of thing. TBS VTXs, there's plenty of choice. But what you'll get is a manual which will tell you how to use it, and the most important part is the wiring diagram. Now, what we're going to be interested in on this setup is our DC in, so that is a 7 to 26 volt input, our ground, and our video. They're the main three connections that you'll be hooking up on the video transmitter. And also we have smart audio here, which, as I said, we'll stick that on. Why not? It's here, it's one connection. And what that allows you to do is change the channel and the power through the flight controller. It's really, really handy. You can, you know, set it up so that it's on low power until you arm automatically. Some really cool stuff to actually preserve the life of a VTX and also save power. If your VTX doesn't have smart audio, it might have something called Immersion RC Tramp or IRC Tramp. That does the same thing, so you can hook it up in the same way. You just use the Tramp pad instead of the smart audio pad. And all we're going to do is connect that up to a transmit pad on a UART, so a TX pad. So because I'm doing this using pin connectors, all I'm going to do is add a servo connector on here. The annoying thing is the way this is running, it's left the cable quite short. Maybe I'll stick it right here in front, which is not ideal, but at least for the demo purposes we'll get everything hooked up. I could always extend the cables, but to be honest, I just want to get this done quickly so that you guys know what you're up to when you're installing yours. So what I'm actually going to do is take note of what wire does what, just to make it easier to install. So you can see this diagram has actually been taken from the perspective of the other side, based on the MMCX connector, the LED, the button and the microphone. So we have a microphone, connector, LED and button. So all those connections are from this side. So what we can see is smart audio is white, our power is orange, ground is black, and our video is green. So my scribble now lets me know which cables I'm going to need to connect. And what I'm going to do is have a quick look at the plane and see where we need to connect it. So the bottom row is the VTX. So we have the video out, we have our power, which is set to 9 volts, we have ground, and then nicely we have TX3 right next to it. So I can actually just use a 4-pin connector here and connect everything in one go. Now this is something I would highly recommend getting, and it is a set of DuPont connectors which has all different sizes. It's got the connections and also the pliers to allow you to make your own cables. Having the ability to make your own cables makes this hobby so much easier. Without this, what you could do is take an old servo cable or a servo extension lead, cut it, join the wires, but you've probably potentially got to buy the servo extension in the first place, so having connections like this is just so much easier. Right, so let's get our connection made. I'm just going to cut all these cables about the same length, which, yeah, I may need to extend them later, but it's not a big deal. And as I mentioned, I'm going to just run a 4-way plug so it can just go straight into that UART. So to do a standard servo plug, it's these little silver connections here. These longer pin ones are if you wanted to actually make an extension. So when the plugs join together, that they sort of slide in like that. But for these standard plugs going onto pins, it's these sort of flat ones here, and I just want a 4-pin connector. So making up these leads is actually really simple. Just cut a little bit of cable shielding away. I usually give it a little bit of a twist and pop the crimp into the crimpers. Now on one side you'll see that there is a slightly recessed side, so that side there is smaller than that side. You can just about see the step. I know it's not too great to see in this video. So with the stepped side, you would put these 2 longer pins in there and then just start closing it up. This is quite awkward. I'm going to try not to say that so much in this video. We do appreciate that it's not the easiest thing in the world to do this while not looking at it. And I usually just get it so that it's just about going to start actually clamping down. And then all we do is insert the cable in there, and you just want to make sure that it doesn't pop out on that side. So, and also you just get a bit of the shielding or the actual silicon wire part into where the clamps are going to go. So about there, that's looking okay. And then just crimp it. Now on some crimps, these ones look okay, but on some crimps there are some smaller little tabs further up that also need crimping. Just slide it a little bit further up into the crimps and that will be fine. But you can see the white part of the cable is in the bottom part of the crimp, and the inner conductive part of the cable is crimped by those top bits. That's exactly what we want. So I'm just going to get the other 4 done. Okay, so all 4 are crimped. We've got our little plasticky bit there. So let's get the plane back and just take a look to confirm everything. Right, so I usually do these things with the holes pointing towards me. And on a standard servo plug, that would be ground, power, and then signal. But because we've got a few more things here, we sort of need to take a look at it. So the first is going to be VTX, which is video, which is the green. So that one just goes up into here and it will click. If it's the cable's a little bit thin, you can actually poke something up inside there. The next one will be power, which is our orange. Then ground. And then finally we have our smart audio, which is the white. So all those are in there. You can give this little plastic bit a push down just to make sure that everything's not going to come out, but that's basically it. So that would now connect straight onto these pins here. And that's our video transmitter done. So that will plug into the antenna. We can then, sit that wherever we want. That might work for the time being, something like that. And then if this is permanent, you can double-sided tape it down, or I will just be using something sort of temporary just to hold that in place. But that's looking pretty decent. Right, so that is our video transmitter done. Next we need to be able to see where we're going, so let's think about the camera. Okay, so for the FPV camera, I've actually just gone for the same one that comes in the plug and play kit. This is basically so that you guys can see the quality of the camera when I show you a flight video later on. This is a Foxeer Razor, and to be honest, I've used one of these in my mini AR wing, and the mini size version is actually pretty decent. It's a cheap camera, but it works well. The idea is that it lives up there. So if you're using a smaller sort of nano size camera, I believe that's what these plates are for. But I'm tempted to try those anyway, because it might bring the camera up a little bit, so you might not get so much of the nose in view. So let's have a quick go. So sorry about that, I was sort of rushing ahead. I need to take it as if you've never seen an FPV camera before and what you get. So black plastic thing usually comes on the camera. It's just a lens protector. Just don't forget to take it off before you fly. And then you get a bag of bits and pieces. So what we have is this little joystick here, which will plug in to the back of the camera. And what that will do is let you change settings on the camera's OSD, such as you can, if you don't use a flight controller, you can put basic information up there, like the battery voltage, a pilot name. You can change all that with this little device, but also you can fine-tune the image settings, and on some cameras they actually allow you to change between, so this one will allow you to change between PAL and NTSC. Some will also change the ratio. So before we try one of these side plates on, I just want to mention a couple of things to look out for when you're getting your own FPV camera. So on this box we can see a couple of things. So we have our 1200 TV lines, and it's a CMOS type sensor. The more TV lines, the better quality of the image. The CMOS is just the type of sensor used. There's two main types that you'll get in FPV. Most of them these days will be CMOS, but you do still get some cameras that are using CCD. Personally, I prefer the image you get with CMOS. The lens and color, the color doesn't really matter, it's just the color of the plastic. The lens on this is a 1.8. You can get different lenses, and what that will do is change the field of view. So a 1.8 is quite a wide field of view. If you go up in millimeter sizes, it will actually reduce the field of view. So for example, a 2.5 millimeter lens will have a smaller field of view than this one. So With this it may be around 160 degrees, with the 2.5 maybe around 140, something like that. The input voltage is just the voltage the camera can accept. The maximum voltage is something you may need to pay attention to. If you're running it off a flight controller like this, then it's not a problem because we'll be using 9 volts in this case. The aspect ratio is in reference to the sensor used, but that will also be determined by your goggles. Your goggles will have an aspect ratio on their sort of little screens inside the goggles. My goggles are using a 4.3 aspect ratio, but you can get some goggles that use 16:9. If that's switchable on the camera, it doesn't matter. You can switch it to whatever your correct screen is, but if you have to buy a fixed one, then just make sure that it matches your FPV goggles. The system, PAL or NTSC, is basically the video system used. So PAL runs at 25 Hz, NTSC runs at 30 Hz. So you get a slightly faster refresh with NTSC, but NTSC has less visible lines. So you'll get more information on your screen in regards to stuff like the OSD, that sort of thing. So I'll be running PAL on 4.3, and that's all there really is with this camera. Some cameras have a few extra settings, but to be honest, nothing that you need to worry about when you're actually making your purchase. Alright, so let's try these little things and see how they go. Alright, so what do we gain by using this? So if we're gonna use this with this camera, we will need to cut out some foam. But what do we actually gain? I'm going to take one side off, which I know I've just put it on, but just to get an idea of what we might actually get. So it will move the camera further forward, and also we can adjust the angle of it. So am I going to bother with that? It will make the wiring a little bit easier because of where the hole is. We won't gain any height as far as the lens goes, but it'll be further forward. What's going through my head at the moment is what the view is going to be like with that on there. If that's further forward, we'll get less of this nose in, which I like the nose, but I don't really want to be seeing it. So I was going to be cutting foam out here anyway, but these little adapters might just mean that we don't get so much of a nose in view. I think it's going to be a personal choice. I think what I'm going to do is just stick it in there for now. So you can see we're going to have to cut stuff anyway. Actually, how can I get this? There we go. So you can see already that lens is touching this already. So we'll definitely have to cut this. So yeah, I'm going to use these plates. Decision made. Let's go for it. I do want to fly with this nose on at some point. Right, so that camera is the same width as the hole. So what I need to do is enlarge the hole by the width of these plates. So I'm going to be using my big craft knife just because I'll get a straighter cut. I'm going to hold that on there. Which again, not easy. I don't think this would be easy if it wasn't on camera. Alright, so that's given us a line. I think it's getting close to the point where I need a new blade in here. Fresh blades just cut foam so much nicer. And the same on the other side. Now when it comes to cutting foam out, it is actually better to use like some sort of heat gun. You'll notice if I turn this round potentially that if it focuses, there's a few sort of bubbles in here. It's just part of the foam process. It just doesn't sort of melt every single bubble. So you do get areas in the foam where it's just sort of like bubbles are up and melted down and nice and tight. But for little slivers like this, cutting is usually fine. So I did notice on the last video that I am getting some stuff out of camera. So apologies for that. Alright, so how does that fit? Yeah, the foam could do with a little bit more trimming away, but it's not bad for a test fit. What I'll do is I'm just going to trim a bit more of this away from the side, and hopefully we'll get a bit better fit. I need a new blade. See how much better a brand new blade is. That is better. So now with that in place, our camera is no longer touching on the bottom, so we can tilt that however we want it. There is a slight gap, so yeah, we can adjust that to whatever we like. And yet we still need to cut a bit out of this nose, but where it's a bit further forward, hopefully it'll be a bit nicer. So what I'm going to do, just for now, is I'm going to put some marks in the foam where that is. And I'm just going to cut away a piece of foam. And we may, of course, need to keep on cutting away just to get it to fit nice. But that's a pretty decent start. You can see it actually pushes in at this edge, so we might not be able to have a nice sculpted one. But see, a sharp knife works so much better. There we go, that's clipped on quite nicely. And what we'll do is we will take a look once we get this wired up at how it looks, so we can actually adjust it. So of course, before you fly it, if you are going to be using this setup, make sure to glue these plates in here. What I'm potentially going to do is maybe hot glue them in, so it's sort of a temporary setup. I'm considering a pan and tilt up here, but we'll see how that goes. But definitely for the maiden I'll be using this, so I'm thinking maybe just some hot glue to hold it in, because that's easy enough to get rid of at a later date. Right, so next up what we want to do is wire this in. So our camera comes with this lead here, and also in the Dolphin kit we have this lead, which if you notice is exactly the same. So we can actually run this cable all the way to the back. So I'm going to take the nose off, it might be easier to access. Unfortunately, again, just because of the depth of this model, I can't actually show you what's going on. But this hole here goes down and comes out just above this hole at the top end. So it's easy enough to poke the cable through and get it out towards the back. So let's get it down and through to the back. And that will connect into our FPV camera. The little clip part that you can see here will actually match up to that little hole in the top. So we plug it in there. It's well worth, of course, making sure that the pin order is correct. So on here we have VCC ground video, which is red, black, yellow, and that's all good. So we can just plug that in, and I'm going to temporarily push that back in here again. And there we go, leave a little bit of slack in here. Now, down the side, there is this recess here, which is for our video cable. So it's a really well thought out kit, this. I wonder how far back this will reach. So what I will be doing is putting this cable into the little groove here. It just keeps everything out of the way, because of course you're going to have batteries here. And to hold that in place, all I'm going to be using is a bit of blender tape, which, you know, is a fantastic tape that you can use for so many different things. Now, usually I probably wouldn't tape it in until I was certain everything was where I wanted it. But because I don't know how long this cable is and whether it will reach our flight controller well, which it looks like it's going to be fine, but I don't know how long to extend the cables if I need to, unless everything is positioned properly. So I'm going to get it in with tape up until this back area, which will still give us plenty of working room. Right, so that cable, even around the very outside, will just about be enough. It could be extended a fraction, but if I'm not using a rear battery, that's actually pretty decent. Thinking about it, we could put it underneath the rear battery, and then we have loads of cable. So yeah, that will do nicely. So the next step is to do the same as with this and add some crimps. So looking at our cable on our flight controller, we have C1, which will be the yellow, we have 9 volt, which will be the red, and we have ground, which will be the black. So only 3 crimps needed this time, and I'm just going to do this exactly the same as I did the last one. There's the leads have been pre-tinned with solder, so I am just going to cut that off so we get just the regular cable. But other than that, it's identical, so I'll be back when that is done. Okay, so we have our crimps, so I'm just going to do this as I would do a normal servo. So holes towards me, we have the signal, which is in this case is our video, on the outside, on the left, power in the middle, and ground on the outside to the right. And that of course matches up with what's on our flight controller here. This one doesn't seem to want to poke in so well, so you can just use something to poke them down in until they click. That's it, all clicked. So back underneath, took it out just because it was a bit easier to do the work. And then we have our camera 1, which is our yellow. That's what we're going to use for our key. So that is here, and connect that into there like that. So that right there is our video done. Got plenty of cable, so Again, could use a bit of Blenderm tape or something just to keep that nice and tidy. But that is our video system done. Right, so we've got two things left to get hooked up. That is our GPS and also our receiver. Now, if you remember, we're going to be using these two UARTs at the bottom here because they have the 4.5 volts on this red. And what that means is when we plug into USB, these will be active. So it's much better for setup. And I'll be using UART 2 for the receiver and UART 6 for the GPS. So for the GPS, I've decided to stick it up here, which means a little bit more foam cutting, but I think it'll be a nice place to put it. And also we can finish it off with, say, a 3D printed cover or something like that. So with the GPS, there's no real orientation to worry about. If they have a compass, usually this plug is at the back, but it should have an arrow on there. The only thing that you need to be sure of is that this is facing upwards. This ceramic thing here is the antenna. These scratches in it, they're absolutely fine. That is to actually tune the antenna. So it's good that they're there because the antenna has actually been tuned. So what I'm going to do is just position it where I want it, and what I'm then going to do is take my knife and just sort of cut into the foam slightly inwards towards the actual GPS module, just so that it's a bit of a tight fit. And try not to move it to get the other end done as well. So hopefully we can now see some marks in the foam as to where we need to cut. It's tricky to see. Even for me here, I can see this one here, which is coming down here. I can see a bit there. That's the bottom. So that's a bit better. And all I'm going to do is cut into it a few millimeters. And then we're just going to, I think for this we could actually sort of carve because it is on a curve. So let's go in at a slight angle just to remove some material. Once we get to that line we stop. Then we can go back this way. So you can see we've not gone down far at all, but you just basically want to get lower and lower after test fitting. So let's go back the other way, just to try and get the same depth at the front and back. This is actually sloped, so what I'm tempted to do is get it so it's in at the back. And then at the front it might be a bit deeper, but I can maybe make a 3D printed cover or something to go over. But we can see this is reasonably thick, so we do need to go down a fair bit more than that anyway. I think that's going to be good for that side, so just spin it around. And do exactly the same thing. So I'm not going all the way down. I'm just going to go slow. We do have a hump in the middle, which I'm going to try and cut straight from this direction. We're going down a little bit deeper this end, but that doesn't really matter because we need to anyway. Let's try and get that straight. The length looks about right, but it could do with being a little bit wider. But for now, I'm just going to try and get the hole sort of fairly even. Sorry. See, there's a hump. What I usually do with humps is try and slice across at about the same depth in the foam, and then I will just go in with some pliers and just pull it out, which is not the neatest way of doing it. And actually you can get a melting tool, which Adam G does FPV, has one. I really need to try and get hold of one. If you've not seen Adam's videos, go check them out because he does some absolutely fantastic flight videos. They're absolutely brilliant. So I'll put a link to Adam's channel. Decent bloke and some awesome flight videos. See, it's not bad. The size of the hole, it still just needs to go down a fair bit. If you look at that, it's about half a blade. So yeah, it's quite a lot. It may be that we even have to just take a big hole out and put something underneath to support it. So I don't mind if I go too deep because I probably will make a cover anyway. Yeah, so see, when we get deeper we get the sort of bubbles of foam rather than actual solid pieces of foam. That's where the sort of melty cutty tool comes in, very useful because you don't get that. That's also quicker. So I do need to get myself one of those. And if I do find out where to get one from, I will put a link in the video description. Okay, so let's try that. It's the side still slightly. Unfortunately, when it comes to foam, these blades don't stay sharp for very long. that's better. And that is actually pretty spot on. So if you look from the side, we've got a slight lip there, but that's no problem. I might even just put some white vinyl over the top of that. But that's in. So what we need to do now is make the hole for the cable. So if we can get this back out, we have our cable at the back here. So all I'm going to do is actually melt this time a hole in the bottom at the back, just so that the cables can go through. Right, so I don't have a cool melty tool like Adam G does, but I do have an old servo rod. So basically I bought some servo rod, only needed that much of it. This is left over. So what I've done is added a few bends so I can get in there and melt holes. I also have a few straight ones if I need to melt longer holes. Now you can heat this up with a lighter, but I prefer flambe torch. Obviously don't point this towards your phone. So this is nice and hot, and just going to melt a hole in the back there. Job done. Yeah, there's not a lot of foam underneath that, but there is a big block there, so the GPS is actually going to be well supported. The trick comes now is putting this somewhere where it's not going to melt anything. Right, so next up we obviously need to wire up our GPS. So at this end it's not a problem, we're just going to do the crimps again, the same as we did for our VTX, which with the 4 connections. But this end we need to know where our wiring goes. Now in the pack we get this cable which plugs in like that. So we can assume that this is power and ground, and we have a green and a blue, but there's no instructions. This is all we have. So what goes where? Now with this one it's actually using silicon cable, which is nice. With the BN GPSs, they are a really stiff cable. So what we need to do is check out where we bought this from, or maybe even the TBS website, to find out where the cables go. Right, sorry I'm in the dark. I've put the light up here to try and get this working better. So hopefully this is actually working better for the build, but I'm in the dark at the moment. Right, so I bought that GPS from Hobby RC, so let's have a look on here and see if there's a wiring diagram. And perfect, there is. Okay, so what we need to take note of is, I would forget for all these GPS models, whether it's this TBS one or the Baytan BN, forget the wire colours. Half the time they don't match. What I usually do is look at where the LEDs are and then the order. So I'm going to put that on that camera so we can sort of match it up. And actually on this one the wires are the same colour as on here. And so we have our power in, TX, RX and ground. So our TX on here is blue, our RX is green, and what that means, obviously at the flight controller we need it the other way around. So our blue cable will go to the RX on the flight controller, and the green cable will go to the TX on the flight controller. But what I'm going to do is just make a note, because that is the smart thing to do. Then I won't forget. Actually, I'm going to leave it on the screen. So my screen is sort of, the camera's here, my screen is underneath, so I can just go backwards and forwards. But if you haven't got a screen near you, write it down and then we know what's what. Back over here, obviously these cables are not going to reach where we want to go, so we are going to have to extend them. We've got plenty of space to get the cable up through there, or we should have. Yeah, so that will fit nicely through that hole. And actually we're going to want it through the hole just to work out how long we want these. Twist them as well. Okay, so let's put that about there. Should have left it connected to the GPS because that will actually hold it in place. So I'll stick that there. And I'm just going to use my standard, what is it, 28 American wire gauge cable to extend them. These are silicone cables, so just what we need. Right, so let's hold the red up to there. I'll bring it around. And we're going into this UART here, so that will give us plenty of length. So let's cut that off, and then I'll just cut the other wires to match. Right, so in the last video I did a lot of soldering with close-ups of the soldering, so I'm not going to be doing that in this video. All I'm going to be doing is joining the wires together. Actually, let's do one. Right, so I'm just going to be cutting a bit of the shielding away. And actually I'm going to trim off all the pre-tinned cables. Let's get them all about the same length. So again, cut off a bit of the shielding. Twist it and bend it in half. I'll do the same with this one. And I appreciate this is probably not the best way of doing it, but it's the way I do it. And then interlock the two, bend them down, and another twist. And then what I'll do is add a bit of weight on this side so I can give it a little bit of tension, and then I will be soldering that. There's no need for flux or anything like that. I'm just going to wet the tip and then heat up the wire and apply a bit of solder. Job done. Of course, then what we need to do is put some heat shrink on here and shrink it down. But I'm just going to carry on and finish wiring this up, and I'll be back when that's done. Okay, so we've made up our cable. The next thing that we need to do is the same as we've done with these two things, is basically add on our connector. So let's take a look at the order, because that's the only thing we need to really worry about. So starting on the outside, we have our ground, then we have our power, then we have the RX, which is going to connect to the blue wire, and we have the TX, which will connect to the green wire in this case. Obviously your GPS may be different, so make sure you check the documentation. But again, I'm just going to use a 4-pin header. So I'm going to get that wired up because, again, you've seen me do 2 of these already, so I won't waste your time showing you me doing another one. And there's our finished cable. So on our connector, we have black to ground, red to 4.5 volt, blue, which is the TX from the GPS going to the RX, and we have a green, which is the RX from the GPS going to the TX. So that will plug into our UART number 6 here. And then we just need to run our cable round and poke it up through the hole, which is going to be the interesting part. It's not too bad. Connect the GPS module. And that's it. We just pull the cable through a little bit and then tuck it in. Job done. So again, we can tidy this cable up. Could even go underneath the plate again with the video. Right, so we're getting there. The next thing, or the final thing as far as the FPV goes at this point, is the receiver. I did just have a thought, where our cables coming through could be interacting with that, but actually no, it's actually popping in just nicely. If you do put your GPS here and have problems, you could always just cut a V in here, so you still get, you know, the tab in as far, but there's just a little V where the cable is. But that is absolutely fine. That's on there. So as far as wiring up the receiver goes, it's actually very similar to what we've just done with the GPS. What we're going to have is the ground and power again, and then the only thing that's going to vary is our pins here. Now if we're using the Crossfire protocol, so that will be Crossfire and ExpressLRS, we're going to do the same as we did with the GPS. So the TX from the receiver will go to the RX here, and the RX from the receiver will go to the TX here. So that is going to be just wired exactly the same as the GPS. There's no issue at all when it comes to that. So I'm not actually going to show you how to do that in this video, because it's no different to this. It's just connecting it to a receiver rather than connecting it to the GPS module. But how you do the wiring is exactly the same. It's a UART at the end of the day. It's all the same. We can move this from here to here if we wanted, and it would work. Where things do get slightly different is with FrSky. Now with FrSky, things get a little bit more complicated, but not really. If we're using an F7 board or an H7 board like this, then it's not really a problem. The issue is something called inversion, which basically means the data sent and received over the UART is backwards. So a 0 is a 1 and a 1 is a 0 effectively. The H7 and F7, they can actually invert on the chip, so that's not a problem at all. What the problem comes when we start dealing with the F405s or F411s. Not that I'd recommend an F411. Take the F405 that we have here, you'll notice that there is an SBS pad, which is short for S-bus. And what that pad is doing is basically that is the same as the R2 pad, but there is a hardware inverter. The F405 chip does not have inverters on the chip, so it has to have a hardware inverter to go between those two pads. So SBS and R2 are effectively the same R2 on the UART, but there's a hardware inverter between the two. So if you're using an F405, the ideal situation would be to use F-port if your receiver has got an inverted S-bus pad on it, because what that means is we can just use a standard transmit pad, so it doesn't actually matter. You don't need to worry about inversion at all, because it's been put the right way on the receiver. The issue comes is if you have to use regular F-port, which you can't use on this because it hasn't got an inverted transmit pad. So you'd have to then use S-bus and SmartPort, which is the older technology. It works fine, but you need to set up an extra wire. So on the F4s, if you're using a FrSky with an S-bus setup, you would connect your S-bus pad to the S-bus, and you would connect the SmartPort to the T2. Now, on this flight controller, T2 automatically changes to soft serial, which is fine for telemetry. You should never use soft serial for the actual command, so that's why we can't use it with standard F-port. With the F7 and H7, we don't need to worry if we've got an inverted pad or not. We can just use F-port regardless, because the flight controller can invert it in hardware. So what I'm going to be doing for the wiring of my receiver, so I'm going to be using this R9MX, which does actually have an inverted S-port pad. This third pad up here is the inverted S-port, but because this has got hardware inversion, I don't need to worry about that at all. So what I'm going to be doing is using this pad here, which is ground, voltage in, and this is the standard smart port or F port pad. So I'll be using that to the TX and then the power and ground. There's no need for an RX on here because F port is bidirectional, so it will talk both ways. If you were using the F405 with this receiver, don't use this pad here, which is the standard S port. Use the one next to it, which has the hardware inverter. So if you use that, you can use the standard TX. Well, what I'll do is I will show you in the setup on iNav how you can actually use it with this inverted setup, because you do need to change something. When we connect up on this one, it will probably just work straight away. So again, this is just soldering. I'm going to come back when this is done. Okay, so here we have the receiver wiring. So it's pretty simple: ground, power, and F port in this case. But again, if you're using Crossfire, you would just have one to a TX, one to an RX, and then at this end you would have the TX to RX and RX to TX. So again, it's exactly the same as the GPS. So that will then plug into our UART 2. And then the receiver will be positioned. Now at the moment I'm going to leave it loose because there's a bind button on here which we will need to get to. But as I keep saying, this is sort of all temporary positioning for me, so I will probably just be taping that here. So I'll have the antenna just taped on the stabilizer and the receiver just taped inside just for the time being, because I move stuff to wings. But anyway, that is the receiver wired. So that does just leave one other thing that we had at the start of the video, and that is that our servo leads are too short. I'm looking at the time on the video again, and it's already pretty long, and I think at this point you guys know how to solder. So what I'm going to do is just share with you a little trick, but I'm not going to do the whole job now just because it is basically just soldering. So because we want to keep this cable at a reasonably sort of slim profile, what I'm actually going to do is stagger the cuts. So I'm going to put one there, and I'm going to put one maybe up here. So let's try and separate these wires out. Let's use the snips. So one cut there. Where's the other one? One cut there. And the red will actually be about halfway between the two. So let's go about there. And then when we add our extension wires in, when we add our heat shrink and everything, these joints are all staggered. So physically taking up less space is what I mean. So that's just one tip, but of course all we need to do is, with a wing installed in the plane, all we need to do is work out how much extra cable we need. So just hold that on the servo plug, bring that down to about here, which is where we're going. So for that wing, we would need 3 pieces that length, and that will join up this one. And I've actually just cut that one, but it's going to come to about here, so I can estimate. So that comes to about here. Let's go to about there. Yeah, so pretty similar lengths. But all I'll be doing is cutting black and yellow, same lengths. and then splicing them in and heat shrinking them, the same as I did with the GPS. So it's exactly the same as that, but I think the video is a bit long now, and once this is done, everything in here is done. Right, so that's everything in there done for the minute. So in the next video, what we're actually going to be doing is setting up our transmitter. This may seem like a weird thing to be doing, but I'm taking this as you're all complete beginners. So to actually progress in iNav, we need a working transmitter, and we need to get it bound to our receiver. So in the next video, we'll be setting up a model on our transmitter. Now, again, I think I mentioned it in an earlier video. I'm assuming that we're using an OpenTX or EdgeTX based transmitter, and I will be using the iNav fixturing group standard model for this. That will make setting this up a hell of a lot easier, so we can actually get on and do this quicker. So that will be the next video, and then after that we're finally into iNav, where we can start setting this plane up. So before we finally wrap up, if you have any questions about anything that I've done, or would like any clarification, please don't forget you can use the comments, and any comment in there I will try and answer as best I can. And if you wanted me to go over some stuff in more detail, then of course I can do that. One of the things I'm planning on doing that I need a bit of time to get done is on the website I'm going to set up some wiring diagrams for the 3 most popular flight controllers, maybe include some of the newer ones as well. Let me know what you think in the comments. But thank you very much for watching, guys. If you found this video useful and enjoyed it, please remember to give it a thumbs up, and also clicking the subscribe button and the bell icon will help get this video out to more people so they can learn how to set up their first plane with iNav too. Thank you very much for watching, guys. See you on the next one.